On January 17, 1995, at 5:46 a.m., a large earthquake of magnitude 7.2 struck the Hanshin-Awaji district. In Kobe City, the quake was very severe. Fatalities totaled more than 6,500, and many buildings were damaged, to an estimated cost of $100 billion. However, there was a building that was not damaged in this disaster at all. It was the West Building in Kitaku, Kobe City. Household articles, windows, doors, and walls of the building were not damaged, nor were the mainframes. A similar example occurred in the USA during the Northridge earthquake of 1994 that hit the Los Angeles area with a magnitude of 6.7 and resulted in substantial damage. A building located 36 kilometers southeast of the epicenter did not suffer any damage. It was the University of Southern California Hospital. The reason is due to a system that is able to reduce the vibration of an earthquake in a building. These two buildings use seismic isolation systems. During recent earthquakes in Japan, the positive results of the seismic isolation system have been confirmed. Seismic isolation systems compared with conventional systems. What is a seismic isolation system? The most common protection system is an earthquake-resistant structure in which the foundations are installed directly on the ground. In the case of these structures, the upper parts of the building shake intensely during an earthquake. The building is damaged, and interiors such as walls, furniture, and equipment fall down, are moved, or damaged. The main cause of the damage results from earthquake vibration. With seismic isolation systems, devices for seismic isolation are installed between the superstructure and the foundation supporting the building. This enables slow horizontal movement and prevents damage during an earthquake. Comparing a seismic isolation system with a conventional structural system, shaking in a seismic isolation system is reduced by 50 to 80%. But a large space is needed for horizontal movement in a seismic isolation system. For example, the usual lateral movement during big earthquakes is around 30 centimeters. As a result of adopting a seismic isolation system, not only the main frames of the superstructure such as columns or beams are protected from damage, but also the interior of the building, such as walls and furniture, are kept safe. Protection of human life, preservation of property, and the building's functionality are realized. Devices for seismic isolation. Devices for seismic isolation consist of two kinds. The first one is called a bearing or an isolator that is set under a column and supports the building's weight. During an earthquake, it is displaced slowly and softly in a horizontal direction. Elastometric isolators that are made of thin laminated rubber sheets with steel plates are popular. Recently, sliders and ball bearings are also used as isolators. The second type of device is called a damper. This absorbs the energy caused by shaking during an earthquake and reduces the amount of shaking in the structure. Metal dampers use the plasticity of materials such as steel or lead. And fluid dampers use the flowing resistance from the viscosity of materials such as oil or silicone. Laminated rubber isolators with lead plugs are used as isolators and dampers. Also, high-damping laminated rubber isolators are used. A seismic isolation system was first used in Japan in 1983. The number of systems increased rapidly as a result of the Great Hanshin earthquake. The building standard law was revised in 2000 to increase the use of seismic isolation systems. This chart shows the proportion of seismic isolation systems applied in buildings. Almost half of them are installed in condominiums. From the experience of the Great Hanshin Awaji earthquake, people became aware of the need not only to secure human life, but also to protect property and keep the functionality of a building intact. Installation into detached houses and important government buildings has been increasing. The system can also be applied to existing buildings and will result in reduced shaking during an earthquake. This is called a seismic isolation retrofit. An earthquake is a natural phenomenon that cannot be predicted. As such, we must work towards limiting its effects. The seismic isolation system has been applied to various buildings. For an installation, it is necessary to create a certain amount of space around a building. A seismically isolated building moves a lot during an earthquake, so a clearance of about 50 centimeters is necessary. In the case of seismic isolation at the base, a retaining wall is required to keep space for the movement of the building. The maintenance of devices for seismic isolation is important because the devices must always function perfectly during an earthquake, so regular inspection is necessary. In the case of seismic isolation at the base, retaining walls and double foundations must be constructed. Also, it is necessary for plumbing and wiring to be kept flexible, so they can move with the movement of the building. These factors increase the cost. However, because the seismic force on a building is reduced, it is possible to reduce the size of beams or columns, resulting in a reduction in the overall cost. Thus, there is both an increase and decrease in necessary costs when adopting the seismic isolation system. However, when a large earthquake occurs, no restoration expenses are required for a building with a seismic isolation system, unlike conventional buildings. When you consider the lifetime costs, a seismically isolated building is advantageous to a conventional building. Though it is difficult to predict large earthquakes, the seismic isolation system enables a building to remain safe. When constructing a new building or renovating one, consider adopting the seismic isolation system.